like, well, wait a minute. Everyone keeps saying that plants decided to migrate to land. Let me check it out. So I actually did my homework, got in with some geologists, some biophysicists, sent a lot of emails to a lot of professors, and apparently that pushed algae onto land. This is why the first type of eukaryote organisms, aside from just plants that were like bugs, had armor, because the gravity was intense. And this is why it created a very hospitable environment to armored organisms and special plants. Now, the plants that arose were all chlorophyll. From stem to trunk, they were massive. They looked like sponges, right? Sponges. And all they did was grow. And because they migrated to land and they grew, they pumped a lot of oxygen into the atmosphere because they cleansed all the carbon dioxide. So what happened is that as this carbon dioxide was being pulled from the atmosphere, we saw gigantic trees and plants come to fruition. And this made them extremely tall. You think the redwoods are tall? Boy, even taller. And then we had dinosaurs and big ass bugs. And I've said this many, many times before. If we recreated a dinosaur now, like Elon's like, yeah, we got DNA, because we could do that, right? They would crush under their own weight. And it's because of the gravity, but also because of the lack of oxygen. So our atmosphere has oxygen, nitrogen, and carbon, right? And other things, right? We have hydrogen and other elements. But the cool thing is that, you know, what I noticed through plant physiology was that we have 78% nitrogen, 21% oxygen, 0.9% argon, and a very small percentage of carbon dioxide. So one thing that I noticed was that if you take out the carbon dioxide from the atmosphere, you also reduce the amount of nitrogen you have. And this is why plants were so dominant and big. Because, you know, nitrogen is required. For those of you that are farmers or have green thumbs, you know that you need nitrogen within your soil to make, to have a good soil for your plants, right? And there's specific bacteria that assist. So 78% of our atmosphere actually has nitrogen. Carbon dioxide is 0.03%. So how the heck is it so high? Consider this. So when you create, when you have more oxygen in the air, less carbon. So oxygen back in the times of the dinosaurs was, you know, and I'm talking about plants because I use plants, not animalia, right? I use plants because I was focusing on those. I noticed one thing, that the nitrogen was reduced and the oxygen was increased and the carbon was at the same levels, sometimes even higher. So it wasn't the carbon that was a problem, it was actually the nitrogen. The nitrogen was a problem for the dinosaurs because it contributes to the air pressure. Why do I say this? So there was an experiment where we were checking the cardiac system, yes, of caterpillars. It was the most disgusting thing I ever dissected. I never want to do it again. But it was to examine and see how certain chemicals that wash on the cardiac muscle, and they don't have a heart, they have something like, I want you to picture tendons. You've seen tendons in your meat, that white stuff, right? Now picture them split apart like vocal cords and very stretched out. So the way bugs breathe, right, is by these vocal cords stretching and squeezing to get, you know, these things stretching and squeezing. And it's kind of like a propulsion mechanism for them to move the oxygen throughout them. Now, the way they breathe is by having little holes on the top of their bodies. So they have microscopic holes. suck in with their mouth to breathe. You can't, just suffocate a bug, right? It's like plants. They don't suck in air. The air pressure is what puts the oxygen within their system. So I want you to understand, when bugs back then existed, because the nitrogen was so much less and the oxygen was so much higher, reptiles and organisms like insects were able to thrive because it was a lot more dense. So the atmospheric pressure, because of the density of oxygen, was more prevalent because of the reduction in nitrogen. So nitrogen is what makes an atmosphere inhospitable to organisms or, living things that rely on high density oxygen. It's not the carbon, because you hear them constantly saying carbon emissions, carbon this. It's like, dude, it's like 0.03%. And the thing is, nitrogen actually consumes the carbon. The more trees, though, you have, listen to this, the more trees you have, the more oxygen you pump, the less carbon is in the atmosphere, the more nitrogen will degrade. So this is important because their target isn't carbon, it's nitrogen. Have you ever been pooped on by a bird? Pooped on? Lizards and birds have high uric acid, right? It has to be with the nitrogenous waste that they have. It makes it thick, right? And I'll tell you why. They convert toxic ammonia to uric acid because nitrogen, believe it or not, is actually quite toxic to reptilian species, in the sense of them having the way their chemistry is and the way they work, because they rely on the environment for their body regulation, for their temperature, because they lack the ability for that feedback mechanism, right? It's actually quite toxic to them. And this is why they create this uric acid that it's so, it's not poop, it's urine when they're peeing. That's actually pee, the white stuff that smacks down. Ugh. I'm going to gag on here thinking about it. So that's something that you can realize. So what happened was, all these plants happened and they pumped in so much oxygen that it reduced the carbon, which in turn reduced the nitrogen. So we had an atmosphere that was insane with oxygen. It was so huge that your mosquitoes were like football fields because there was so much oxygen and pressure there. This is why dinosaurs cannot survive here, because there's not enough oxygen in the atmosphere. In fact, there's way too much nitrogen. So they would collapse under their own weight, one, because of the atmospheric pressure and the rate of gravity. Gravity is actually a lot, it's interdependent, not only on the spin, as they tell you, and the movement of the earth, whatever you want to believe, double axis torus, you pick it. But it actually is related with the atmospheric pressure on the organism. So nitrogen is actually deterring massive growth and to be able to sustain large reptiles. This is why all these massive reptiles vanished. And that's because fire came down from the sky and created a rift in the atmosphere, which brought in a lot of nitrogen into the sky. And it balanced out. So I just wanted to kind of make that clear so you understand. Their target is not carbon, it's nitrogen, regardless of what they tell you. That in Antarctica, it has the lowest percentage of nitrogen concentrated there. The only time that shifted was when we had massive volcanoes erupt in the 70s and the 80s. Remember Mount St. Helena's? That created this hole in the ozone that started to increase the rate of nitrogen. Now, the nitrogen in the atmosphere there raises, decreases to about 62% at certain times. This is why you saw Buzz Aldrin saying, I needed air, or they had an air station. It's not about not having enough oxygen. It's not having enough nitrogen to process the oxygen. Okay. Remember, we're made of 5 elements, right? What are they? Hydrogen, carbon, oxygen, nitrogen, and phosphorus. So that is why they needed air. Because you're thinking, wait a minute, what do you mean he was at 9,000 feet and he was out of air? Shut the fuck. This guy went to the moon. Okay. This guy goes to Denver all the time and he's a mile high and this bothered him. That's not how it works. So this 9,000 feet BS, I'm telling you what it is. And this is why terraforming is something that can happen very easily because we understand how the chemistry works. But again, Antarctica has the lowest concentration of nitrogen.